All right, so here we go. So we're still talking about plate tectonics, and there's three type of boundaries that can happen. You have the convergent boundary, which comes together. You have the transform boundaries, which slide, and today we're going to be talking about divergent boundary, which means to move apart. So the Earth is made up of plates, and these plates will do one of those three things. So today we're going to talk about some of the things that are created when you have, a divergent boundary, these geological features. Essentially, a lot of this, the Earth is made up of mostly water. So, this, for example, this boundary is mostly underwater. And these two plates will slide apart. There's a ridge here where the magma will come up and create new rock because the magma hits the water, cools, becomes rock, and kind of creates new land. Sometimes this this is an underwater mountain range that'll happen, and in some areas the land is so high that it sticks up out of the water. Iceland is a great example of that. So we're going to go through this and talk about some of these key vocabulary words and concepts for a divergent boundary. Again, moving apart, divorcing, I guess, going their separate ways, diverging. Just make sure you understand that diverging means to move apart. So in plate tectonics, a divergent boundary is when two plates spread apart and move away from each other, creating the underwater geological feature, mid-ocean ridge that you can see right here. And then here's that transform boundary where the plates will slide side by side in another mid-ocean ridge. A great example of this would be the one in the Atlantic Ocean. Yeah, you see trench here, but remember that is not synonymous with a divergent boundary. That is a convergent boundary because you can see the convergence happening here. You have the continental plate going this direction and this oceanic plate moving this direction, creating that trench. Again, most of these boundaries are found at the bottom of the ocean. Here's that great, wonderful GIF again, where you can see the plates moving apart. And so when this rock is born, essentially, part of the rock cycle, the rock is born, and as it is near the ridge, it is considered newer rock. If you come down and take a core sample along the ridge, you'll notice the date of those rocks to be young. But the further away you move from the ridge, on either side, the older the rock gets. So if you were to get a core sample here, it'd be much older than over here by the ridge. And as the plates move apart, magma pushes up along the boundary, creating the new rock, creating the new land. This creates large underwater mountain ranges, as we know, mid-ocean ridges. And so, as I kind of alluded to, sometimes this happens on land, it happens on land. One of the reasons why is because as that Rift Valley, it's a mountain range, and if it gets high enough, it will stick out of the water, and that's what Iceland is. It's from that magma that has come up out of the ocean for so many years that it has created this landmass. But it is splitting apart. This mid-ocean ridge is splitting apart, splitting that land, and eventually that water is going to seep in here and spread those islands, that turn that one island into two or three. That's the way it's looking right now. The magma pushing up along the divergent boundary also leads to volcanic activity and earthquakes. So underwater volcanoes, earthquakes, those types of things can happen at a divergent boundary. Is that the most synonymous boundary for those? No. You know, volcanoes more often happen at convergent boundaries. Earthquakes more often happen at transform boundaries, but they still can happen at divergent boundaries. And again, can create and does create new crust. It's a great little image here. And again, what's moving these plates, you know, convection, heat rising, and slowly moving through these convection currents. You know, looking at this mid-ocean ridge as an example. On the left side over here, we have a counterclockwise convection happening. The more hot magma on the bottom will rise up and drag across that lithospheric plate and then go back down. And that's what's happening on the left side. On the right, opposite direction, clockwise motion. This is exactly what's happening in the Atlantic Ocean, or, you know, underneath the Atlantic Ocean in the asthenosphere. We have these convection currents underneath the lithosphere, underneath those big plates, directing those plates in the, you know, and sending them in opposite directions, creating that divergent boundary. So just to wrap things up, we have the mid-ocean ridge underwater. That's what's created at the, you know, at these rift zones underwater. And then on land, we call those rift valleys. Underwater, mid-ocean ridge. On land, in Iceland, Rift Valley. And in Africa, the same type of thing is happening. It's called the Great Rift Valley. The land is splitting apart because there's a plate boundary in between that area, where part of Africa is going one direction, the other part's going the other way. And the last great feature I'll bring up to you is the Red Sea. The Red Sea is part of a divergent boundary as well. The Red Sea was a lot smaller, you know, thousands and thousands and thousands of years ago, but it has over time gotten wider and wider and wider, and eventually the Red Sea could eventually be the Red Ocean, all due to divergent boundaries. We'll talk soon.